Our last quadratic application we're going to look at involve trajectory. We know that what goes up
has to come down.
Has to come down, and that kind of models a quadratic. So let's look at this first one. Jennifer hit a golf ball from the ground, and it followed the projectile path here. -16t squared plus 100t, where t is the time in seconds and h is the height of the ball. When does the ball hit the ground?
I don't know.
So far with all of these applications, how have we solved the problem?
By width, the width and the.
Okay, no. Well, once we got the width is whatever, we formed a quadratic equation. What did I do with that equation?
You graph it.
Graph it. Very good. So here's the quadratic. Here is the path of the ball. As I see, that ball went up, and then it came down. Now look in here. Let's see if we can interpret this graph as far as that real world application, that golf swing. What does 0, 0 represent? This point here.
Starting point.
Yeah, where she hit the ball, right?
Up.
Hit the ball, it went up, it reached a max point of how high did that ball go?
That's the peak.
3.125.
No, that's not.
No. 1562.25.
156 feet. So the y-axis refers to our height, and the t is our time. So the ball went as high as 156 feet, and it took how long to get there?
3 seconds.
3 seconds.
Oh.
And then the ball came down, and at what time did the ball hit the ground?
6.25 seconds.
There you go, 6.25. Just as simple as that.
That's all we're doing today?
Yeah, we're just graphing and interpret the result of the graph. In this case, where did it hit the ground? My x-axis represents the ground, right?
Yes.
You could kind of visually see the ball, the path. Here's where it starts on the ground, comes up, and ends on the ground. So the graph actually shows you.
What the?
Next problem. If a toy rocket is launched vertically upward from the ground level with an initial velocity of 128 feet per second, then its height h after t seconds is given by the equation h of t equals -16t squared plus 128t. How long did it take for the rocket to hit the ground? So what am I looking at with the graph? What's going to tell me the answer?
How much time?
Well, okay, how much time and what I'm going to look at with the graph. That tells me how long it took.
But you have to multiply it because it's there. It says multiplication.
Multiplication
Whatever,
with.
the parentheses are already gone. Or it's one of them still right there. The height times the time.
When you.
No. Well, this is just function notation. H of t.
Oh,
So yeah.
I'm learning, Angel.
Yes.
Well, we haven't really talked about functions yet, so that's okay if you didn't know that. Here's the graph of my rocket. The rocket went up, and then it landed. Which of these points tells me how long it took for it to hit the ground?
8
The
seconds.
bottom one.
The
or
x-axis.
This one or this one?
No, 8 seconds.
8 seconds, right?
Yeah.
So this is where the rocket started. It started at 0 time and at 0 coordinate, and then it lifted off, and it reached a peak of how high?
4.
256.
Oh wait, sorry, yes.
4 is how long it took it to get to its maximum height. So it took 4 seconds to get at a max height of 256 feet, and then it came down and hit the ground at
8 seconds.
8 seconds.
So
Very good.
time and then, you just gotta
Jameer is trying to dunk a basketball.
It's because he's black.
I'm trying to take my teacher so I won't get in trouble.
Jameer needs to jump 2.5 feet in the air in order to dunk the ball.
2.5 feet in the air.
Yep.
2 feet in the air. Okay.
2.5 feet. So remember that. Jameer needs to jump 2.5 feet. The height that his feet is above the ground is given by this function. -16t squared plus 12t. Did Jameer dunk the basketball?
No.
So let's look at the graph.
Yeah, I can jump higher than that. Oh no.
Let's see. Span it out. So here's my maximum value. My highest point. Did he dunk?
What was the height of the thing?
He needed to jump 2.5 feet.
That's
2.5. No, he did not.
No,
he missed.
He's short, right? Just barely. The ball probably hit the rim. Boom. Maybe if he had a tennis ball. And then, how long was this jump?
0.75 seconds.
Yeah, 3/4 of a second. Not very fast.
3/4 of a
Yes.
second.
So maybe he didn't try it. Maybe he just like,
Eh,
yeah, okay.
eh.
Hey, for the sound effects. It's gonna look good on camera. Okay. Now let me have you give this question a try. A ball is thrown up in the air. The path of the ball is represented by this equation, -t squared plus 8t. At what 2 times is the ball 12 feet high? Oops. So I'm throwing the ball. Ball's goes up and then comes down. When it goes up, it's going to reach a height of 12 feet here at some time. It's going to come up, then it's going to continue to go up, reach its maximum height, then come back down, and also hit 12 feet at another point in time. What are these 2 points in time?
0, 0.
At what 2 points do I reach a y value of 12?
6.
6 and
2.
2. Yep. 6 and 2. At 2 and 6. So at 2 seconds, my ball is at 12 feet, comes up, comes back down, and also at 6 seconds, it reaches 12 feet. Then it comes down. And then that ball, how long for it to hit the ground?
8 seconds.
8 seconds. And it reached a max height of
16 feet.
16 feet. Okay.